Hi, everyone. So I wanted to spend a little bit of time today going over the quiz from discussion. And this discussion quiz is definitely pretty hard. So don't feel bad if you're really challenged by this problem. It's definitely a problem that pushes everyone, I think, because there's definitely a lot going on and you've had like hardly a week of practice, maybe like less than that just for environment diagrams. So let's go ahead and just jump in and talk about this. What I'm going to do is I'm going to use this left panel to show you Python Tutor, and the right side to show you some of the rules and demonstrate some of the things that I think are like useful details to note. Because sometimes Python Tutor doesn't show like kind of the minute steps, especially for evaluating call expressions. Okay, so without further ado, let's go ahead and jump in. So here I'm defining a function yes, that takes in one argument no. And so if we look at the rule for def statements, what I'll do is I'll make a binding for yes, bound to the value being the function object yes that takes in one argument no, and whose parent is global. And we know that because we're on the outside level. All right, there we go. Yes, bound to the function yes. Next line asks us for assignment statement, n equals 6. So we evaluate that assignment statement by evaluating the expression on the right-hand side of the equal sign. So that's 6, and that evaluates the number 6. So I'll be binding that 6 to the name no on the left-hand side. So we should see no bound to 6, and there we go. All right, this is like the first trick part is right up here. What happens when I look at this def statement, right, which happens to bind to the same name no that was already defined to be a number here? What happens there? Well, no. One thing to remember about Python is that these are all binding. They're just names bound to some value. Even though this def statement looks kind of special, doesn't really use like an equal sign or anything, it still follows the same rule of binding a name to a value. So what it'll do is it'll change or replace this binding for no and point to a function no that takes in one argument no whose parent is global. And we know that this is the case, that it'll replace the name because frames have no duplicate names. So whenever you try to define something that was already defined, you will replace that name's value. So no's value will be replaced with the function no. And there you go. All right, so what's coming up next? This is really, really scary, right? So let's go ahead and spend a little time breaking this down. It's something you probably haven't seen before, so it's totally fine to be kind of freaked out, I guess. So there's a lot going on here. Let's try to break it down. So I have this bit of code. I'm calling yes, passing in yes, and treating that as the operator to this next argument, this next operand no, treating that entire expression as the operator to the operand for. Okay, so let's repeat that again. So let me add in a visual here. So what I'm going to show you is that this operator is going to be the function for this call expression consisting of, let me highlight it, this part. So yes is going to be the operator or the function for this part. And then I need to evaluate the operand, remember, because if we're looking at the call expression rules, we evaluate the operator yes, then evaluate the operands, yes, and then at the very end, we need to apply the operator, this one, onto its operands, this one, and open up a new frame. Okay, so let me kind of show you the game plan. What we hope this will return then is, if I can get over there, a function, right? Because if you look at the structure of this code, we hope that this returns a function because what's coming up next is another set of parentheses. So whenever we see these parentheses, we know that there's something to do with like maybe a function call or something interesting like that. So to be on the lookout. And so we know that this is going to be a part of a bigger call expression consisting of this highlighted section. Yes, of no. This is all going to be one big call expression, with the operator being this evaluated function, the function I get from calling this, from making this call. So this is going to give me a function, which I'm then going to call with the operand no. And then hopefully, after all of that is done, so after I get my no, what I will do, let me highlight it for you. So once I get my no, and I call it with the function I figured out earlier, hopefully all of this will evaluate to another function that can take in one argument 4, right? So here I'm saying that all of this, yes, yes of no, should become a function that is going to be the operator, the operand 4. And that's 4 right there. Okay. So hopefully, so let me repeat that again. So this will become a function to no. All of this will become a function to 4. At the very end, we will then get the final value. So there's a lot of stuff going on. Let's just see how it breaks down here. So we know the first step is to evaluate the operator, yes. And to do that, because yes is a primitive expression, we look up in the current environment, which consists only of the global frame. We look up what yes is in the global frame. So yes, its value is bound to the function yes that takes in one argument no. So what we will get is this function yes. We will get this function yes. So that's the operator. The operand, if we look up yes again, because it's a name, where it's a primitive expression, so we look up yes in the current environment, and we find yes is a function yes that takes in one argument no. And there is nothing wrong with this setup so far. It is totally fine to have the operator evaluate a function that is the exact same function as its operand. There's like no, well, I guess it's kind of like some funny business, but there's nothing like inherently wrong with it. There's nothing in Python's rulebook that says, hey, you can't do that. You can definitely pass a function into itself, and that's allowed. Okay, after that, we can finally open a frame and apply the operator, or evaluate it as the function, to the operand, which is a function. So we'll see here that a new frame is made with the information, with the intrinsic name, yes, right? The parent global, and the binding for no bound to the function yes here. Oops. Oh, you didn't see that. There we go. All right, so here we have frame yes, whose parent is global, the binding no bound to the whose value is bound to the function yes. So now that we've made the frame, right, using these rules right here, what we can do is we can look at the body of the frame, which says return no, and we know that return statements, we evaluate the no, which is a primitive expression. So we look up in the current environment, which is slightly different now. So the environment now consists of F1 and then of its parent global. So we look up in this environment, what is no? Well, no, if we find it right here, is bound to the function yes. So what we'll get is a return value that is the same value that we see here. Look in this bracket. What's here? Well, it's an arrow to this function. So what we'll do is we'll copy down that arrow and put it in the return value space right there. So it's an arrow to that function. Cool. So all of that, we finally figured out that this indeed returns a function, right? Returns a function, yes. So you could think of this as like kind of what I want you to keep in your mind is like maybe this is like an intermediary step. You could think of this call as being equivalent to this call. So yes of no of 4 is the same as yes of no of 4. Basically, there's some slight differences in maybe like how it's set up, but if it's easier for you to think about it this way, I think for now it's an appropriate simplification. So what we will do is we've already figured out that the function is yes. So we've already evaluated that from earlier. So now to evaluate what no is. So the important part here, the really, really important part here is where you evaluate no. Because now we have a problem. There are 2 no's, right? It could be this one or it could be this one. How do you know which one to choose? So the way you know how to choose which no. Okay, yeah. The way you know which one to use is you think about the environment in which we're evaluating this expression. Where are we evaluating this call, right? So let's look at that in our code. So in our code, this call is being evaluated in the global frame, right? We originally started in the global frame, and we know that because we're on this indentation level at the very left. So we're in the global frame, so the environment is just the global frame. So when I look up no, I'm gonna say global frame, hey, no evaluates to this function no. So that's why we know that this is going to be the function no, and now I've evaluated the operands as well. So finally, I can then apply the function that it returned, which was the function yes. Oh no, that happened again. With the argument no, right here. So we'll see a new frame with the intrinsic name yes, whose parent is global, one formal parameter no, that is bound to the function no. So we choose that all in one step, and there you go. We have name yes, parent global, no, bound to the function no. Now if we continue onwards, follow the same rule here. Remember that return statements, we look in the current environment, F2, then global. We find no right here, evaluates to the function no. So let me simplify that again. We've essentially done all this work. We did all of this computation to reach this point, no of 4. We did all that computation to reach no of 4. Yeah, that was kind of perhaps anticlimactic. We did all of this work to get this. So as a simplification, you could think of it this way, but make sure that you go through all these steps. We really want to see it on the environment diagram as well. So when we get to this point, we see that we've evaluated we've done all this work. We did all this work to figure out this is the same as no, as the function no. And we need to evaluate the operand now, which is the number 4. The primitive expression for the number 4 evaluates to the number 4. So then we can finally apply, which is to create a new frame for the function no, and with the argument 4 bound to the former no. So we should see, after I get the return value, we should see a new frame for F3 with the intrinsic name no, parent is global, the binding no bound to the number 4. And there we go. Okay. So I think the part of the scary part is over. We made it past the hump. Here we go. So we've opened the frame successfully. So we can look at the body, which asks us to return this expression. So this is a call expression involving the plus symbol, which tells us to add 2 things. I need to add this expression, this primitive expression no, with this call expression yes of no. So if I go left to right on this on the operands no and yes of no, what I'll see is no evaluates to, in the current environment, 4. So I remember 4, let's remember that. I'm about to compute something that looks like 4 plus something I don't know yet. So the question is, what does yes of no evaluate to? So in my current environment, I need to do that same process. What is yes of no? Well, let's look at it. So yes, look at what yes is, because I'm evaluating the operator. Yes in this current environment evaluates to, well, can't find it in this frame, so I'll look in global. Yes evaluates to the function yes. Cool. Then we ask, what is no, the operand, right? We're looking for the operand no, and it's 4. So I figured out yes is the function yes, no is the number 4, and that way I can then apply the function yes with the argument 4. So we'll see a new frame F4, whose intrinsic name is yes, whose argument is, whose formal parameter no is bound to the argument 4, and whose parent is global. There we go. So it's like this in-between step. I already evaluated no, but since I need to do some extra work here, I need to do this first and then come back and add. So now that we're doing this, let's go ahead and take a look. So what this function says is just return no, and no is just 4. So return 4. So what we'll see here is that all of this is basically the same as 4 plus 4. And so the final return value here, so we'll see it all in one step, is that Python will compute 4 plus the value we returned here, 4, to get 8 in our environment diagram as the return value overall. And there we go. That's the return value 8. So that was a lot. Take a breath, rewind and rewatch parts of this video, or try to follow along, or try to figure out where you thought like you might have had like a misconception, or where it was like especially challenging for you. Definitely feel free to post questions online. I'm also going to attach some useful resources like links to some environment diagram rules and extra practice problems in case you still feel a little shaky on this, which I know I would. So it's definitely fine to feel like it's definitely fine to feel like this material is like still kind of crazy, because that's what we're here to do. We're here to learn. All right, finished. Program terminated.